Hello, my name is Andres Ginebra, and this is the magnetic field of a magnetic bar experiment. Basically, the purpose of this lab was to measure the distance dependence of the magnetic field to a small bar magnet and find its magnetic moment. I used two fundamental equations. The first one is to calculate the magnetic field, and the second one is to calculate the distance dependence, where K is a constant that I'm going to explain later, and R is a distance away from the magnet, and N is a distance dependence factor. For the experiment, I had the expectation that when I was on axis, as I got closer to my phone with the magnetic field was going to be larger, and as I got further away, it was going to be smaller. My data here, as you can see in the chart, and then at the top right, I have the equations I used to model my data. So basically, this is just a distance dependence equation, but I took the natural log on both sides to create an equation like y equals mx plus b. So basically, the slope of this line is the distance dependence factor. The y-intercept is just ln of k. And the distance dependence is the slope, which is 0.5465. So the magnetic moment, I use the equations for the distance dependence. I know that K is mu naught over 4 pi times 2 mu. So then when I plugged in those numbers and solved for mu, I got that mu equals 4 pi to the power of ln K divided by 2 mu naught. Using the value I got for the y-intercept of my plot, which is ln K, I got that mu equals 2.55 ampere meter squared. So the observations and conclusions for this experiment is that when the magnetometer is far away from the magnet, it measures near zero magnetic field in the x direction, and as the magnetometer moves closer to the magnet, the measured x component of the magnetic field increases. The second part of the experiment, I had to use the magnetometer and the magnet in a different axis, so they were off axis. So the distance perpendicular to the start was 0.15 meters, and then I had to read the values and correct the y value of the magnetic field because of the magnetic field due to Earth. And then when I calculated B net, I got that B was 9.26 times 10 to the negative 5 teslas. So for the coding portion of the lab, first I created a function that models the magnetic field. It takes in two parameters, mu, which is the magnetic moment, and r, which is a distance away from the magnet. So I just used an equation and I returned that value. So here I have 6 different observation locations. 2 of them were on the same axis, and then 4 of them were perpendicular to the magnet. So basically, I just called the function to find the magnetic field, and then I created arrows at that observation location. I did something very similar to the off-axis, which is an observation location 45 degrees away. This is similar to the one I did on the experiment. And then I did the same thing. I called the function to find the magnetic field, and then I created an arrow at that observation location. So this is a visual from my coding portion of the lab. As you can see, there are 2 orange arrows which are on axis and are noticeably larger than the rest of them, and then the 4 perpendicular arrows, which are the blue ones, and the purple, which is the 45 degree angled one. So as you can see, that one is the smallest one of them all, and then the orange ones are the biggest of them. So the magnetic field predicted versus observed on the off axis. So when I did the experiment and I found the values, I predicted that it was going to be 9.26 times 10 to the negative 5 teslas. But when I did the computational model, I observed that it was 4.08594 times 10 to the negative 5 teslas. What if I hadn't oriented my experiment to compensate for the magnetic north? So this would change my values, because I would have, in the beginning, I wouldn't have the x component of the magnetic field equal to 0 as I had in my experiment. So then when I performed the measurements, these would have differed, and I would have had to subtract my initial values. from the magnetic field due to Earth. So if I had two magnets stuck together, then the magnetic field would be twice as large at the same given location. The distances would have been way bigger for the same magnetic fields,